Hi everyone, can you both see the whiteboard?
Yes.
Okay. Yeah, I think we can get started. What answer did you get for this question? Okay, good. 50 is correct. Sanvi, do you want to explain?
So what I did was at the end of the second day, she had 32 jelly beans and she ate 20% of what she had at the beginning of the day. So that would mean the 32 jelly beans that she had was 80% of her entire jelly beans she had for this. So if 32 is 80%, then 40 would be 100%. And then at the end of the first day, that would mean she had 40 jelly beans. And then if 40 is 80%, you can do the same thing. So then it would be 50 jelly beans as 100% on the first day.
Good. Yep, that's correct. So yeah, the key idea here is fairly straightforward. I mean, you end with 32 on the second day. That is 80% of what was there at the beginning. So either you can do it algebraically or just think about it, 80% of what was originally there is 32. That must have been 40 initially. And then 20% of the jelly beans were eaten on the first day as well. So if 40 was left at the end of the first day, 50 must have been there at the beginning of the first day. Any questions? Okay, let's move to the second one. Okay, what answers did you get for this? Okay, good. 80 is correct. Sanvi, how did you get 80?
So I'm not sure if what I did was right, but what I did was if you put all 5 scores in, it would calculate the average. So I didn't really think about the order of it. I just added all of them up into the average of that, and that was 80. So that had to be the final number that she entered.
Okay, so it is true that the overall average is 80, but actually it doesn't mean that the last one was 80. So let's think about what is an example where you could end with 80 but not have 80 as the last average. So imagine if the average before was maybe 77. So imagine if you had the numbers, for instance, 75, 79. So you have an average of 77 so far. What would you have to get on the third one to make the average 80?
83.
Close.
82.
So let's think about it. So if the average is 80, what should be the sum of all three of them?
240.
240.
86.
Good.
Would it be 86?
Yeah. So this is one example, right? If the last one, the average overall was 80, but the last one was not 80 itself, right? So it's possible if the numbers were something like 75, 79, 86, 86 might have been the last one, right? So just from looking at this, I don't think we can necessarily say that 80 was the last one, although there's a couple of different ways of figuring out why 80 would necessarily be the last one. Any ideas on that?
She noticed that the average was always an integer. So
Good.
there has to be a specific order of numbers.
Yes, so that's the key here, right? So the average was always an integer. So what does that tell us about, so let's say the numbers were added as first one was A, the second one was B, the third one was C, the fourth one was D, the fifth one was E. So you know one of each of these is, one of them is 71, one of them is 76, one of them is 80, one of them is 82, one of them is 91. So what do we know about A, B, C, D, and E based on this property? The average is always an integer.
A plus B has to be divisible by 2. A plus B plus C has to be divisible by 3. A plus B plus C plus D has to be divisible by 4. And A plus B plus C plus D plus E is already divisible by 5.
Good. Okay, so okay, good. So sorry, 5. Okay, so we know that if I add up the first two, it's the average is an integer, right? So that means that the average times 2 is going to be the sum, right? So the sum must be divisible by 2. Similarly, for the first 3, A plus B plus C, I know the average is an integer. The average is just the sum divided by 3. So thus the sum must be divisible by 3. Same for 4, same for 5. Okay, so now which 2 here will help us figure out what the last one is? So this one has E in it, this one doesn't, right? So let's look at these two, divisible by 4 and divisible by 5. So we know A plus B plus C plus D plus E is divisible by 5, but we also, this is not very helpful to us because we know what A plus B plus C plus D plus E is, right? We know this is actually 400. So what do we know about this 400? It's divisible by 5, but it's also divisible by 4 itself, right? So we know that A plus B plus C plus D plus E is divisible by 4. And we know A plus B plus C plus D is divisible by 4. Does that help us find what E is?
It means that the number that we're going to subtract, so E has to be a multiple of 4.
Good. Yes. So immediately that does help us a bit because we now know that the last number is a multiple of 4. So does that give us the answer itself, or is that not sufficient?
It gives us the answer.
Okay, so 80 is a multiple of 4. We know that. The 80 divided by 4 is 20. Is there any other multiple of 4 in our list?
76.
76, right? So it doesn't necessarily guarantee that, right? Because it could still be 76 as the last one. So imagine if the average before that, we could add 76 at the end and then bring the average to 80 at the end. So let's think about, we know it's going to be one of 80 or 76. So let's think about these other properties and how we can construct. So we know the first 2 need to be even. Some of the first 3 needs to be a multiple of 3. Some of the first 4 needs to be a multiple of 4, and so on. So let's think about, so what do we know about the first 2? What do they have to be? Okay, let's think about it this way. So let's say that 76, so we know the first 4 are some A, B, C, D. Let's say the last one was 76. What would this mean about the average of the first 4?
It's divisible by 4.
Okay, good. We know it's divisible by 4, but we also know what the sum of the first 4 is, right? And we know what the average would be as well. What would that be?
The sum would be 324 and the average would be 81.
Good. So average is 81 of the first 4. Sum is 324. Okay, so now what do we know about the sum of the first 3? It's divisible by 3, right? What do we know about so we also know that the sum of the first 4, is this also divisible by 3?
Yes.
Okay, so does that help us know what the fourth one should be? So we know a plus b plus c is divisible by 3, but we also know what a plus b plus c plus d is if the last one is 76, right? And we know this is also a multiple of 3. So what should d be?
D has to be a multiple of 3.
Good. So what should d be? Are any of these multiples of 3?
They're not multiples of 3, so it can't, E can't be 76.
Exactly. So we tried e being 76, but we tried to fill in the previous ones. But d, you can't find anything because we know it has to be a multiple of 3, yet none of these 5 numbers are multiples of 3. 71, 76, 80, 82, 91. So thus the last must be 80. Now, you can use this to fill in the previous ones one by one, the same way. But let's also, so we've seen one way of doing it this way. Let's also think about a second way of doing this. And let's actually start from the beginning and see if we can fill out the numbers in order and actually get the ordering of all the numbers. So in order to do this, so one trick that's helpful to think about is if I tell you the average of the first few numbers is, let's say you have ABC, and I tell you its average is 75, and the average of ABCD, its average is 78. What should D be? Is there an easy way of figuring this out?
Would D be 87?
Good. How did you do that?
So if you wanted to go from an average of 75 to 78, each number has to increase by 3, and there's 3 numbers, so you have to increase by 9. And D itself has to be at least 78, so you do 78 plus 9, which is 87.
Good, exactly, yeah. So yeah, this trick is useful in that if I start off, if I want to get to an average of 78, I know the sum of the first 3 was 75 times 3, or had an average of 75. So it's basically like imagining I have to increase each of these by 3. So if I have to increase this by 3, this by 3, and this by 3, I have to increase by a total of 9 to make up for the previous ones. And my next one should be 78 itself to kind of match if the average of the previous 3 was 78. So D would have to be 78 plus 9 to be 87. So this trick is useful if you're trying to, if you know what the average should be of the remaining ones and trying to figure out what should the remaining number be to fill that in. So that is a useful trick to kind of, as you're working through this, but let's also kind of build forward and see how we would get the same answer. So okay, the sum of the first 2 has to be divisible by 2. So what are the possible values for the first 2?
A combination of 76, 80, or 82, any of those.
That any of these 2 would work. Anything else that could work?
And then you could do odd and odd. So you could do even, and then odd and odd. So you could do like 91 plus 71.
Good. So these are the 2 possibilities. Or, I mean, it could be either 2 of these 3 even numbers, 76, 80, 82, or it could be these 2 odd numbers, 71, 91. Okay, so let's start with the 2 odd numbers. I think that we can try out first. So what if we had the first 2 being 71, 91? And let's not worry about the order for now. That doesn't actually matter either way. What should the third one be now? Or what do we know as the restriction on the third one if the first 2 are 71, 91?
It has to be under 81.
Why does it have to be under 81?
Because the average of those 2 numbers are 81. So
Good. So the average of these 2 is 81. I don't know if that necessarily forces it to be less than 81. Imagine that we could have something higher than 81 as the next one. It even brings the average up to 82, and then the last two bring it back down. So not looking at these numbers particularly, but I think that may not be itself sufficient. But what do we know about this divisibility by 3? Do we know something about the third one based on that?
It has to be a multiple of 3.
Good. And why is that?
71 plus 91 is a multiple of 3. So you have to add a multiple of 3 to get an average a multiple of 3.
So is there a choice for that? Or if it is a multiple of 3, which one would we have to pick?
None of them are multiples of 3, so that won't work.
Yes, so this is out. So then we can try 7682. Let's see. What about this one?
Could you repeat the question, please?
Yeah, so let's, actually, so one more thing we can eliminate. So right away, we can eliminate 71, 91 won't work. We can actually also eliminate 80, 82 won't work, right? Again, its sum would be 162, which would be a multiple of 3. So that wouldn't work itself. So what are we left with? Either the first two numbers have to be 7682, or it has to be 7680. So let's try either one of these. Let's start with 7682. Let's say these are the first two numbers. What could the third one be now?
It could be either 71 or 91.
Okay, why is that?
The average is 79, so in order to, so now it has to equally divide.
Okay, good. So yeah, basically we want to first make sure that this sum is going to be a multiple of 3, right? So what is 76 plus 82 is 158. So this is 2 more than a multiple of 3. Let's see. Let's double check this. Does 76, 82, and 71 work? Does this sum is this a multiple of 3?
Oh, that doesn't work because that's not even, that doesn't go evenly. It's 76.3.
Okay, yeah. So what number do we need here?
91.
Yes, so let's try that. So what is the sum here? So this adds up to 249 divided by 3 is 83. So yes, this does work. Okay, so now what do we know? If these are the first 3 numbers, what would the fourth number be? Or what do we know about the fourth number?
That number has to be 71 now.
Okay, why 71?
Because if you add all of them up, it divides evenly by 4. And yeah,
Okay, and is 71 the only number that works there?
yes.
Okay, let's double check why. So let's think about what is the sum of 76 plus 82 plus 91?
Yeah. 249.
Good. Now, what we care about is when we're adding this fourth number, right? Let's say we didn't know it was 71. We know that when I add in this fourth number, it should be a multiple of 4, right? Because we know a plus b plus c plus d is divisible by 4. Now, in order to get this d to make the sum divisible by 4, we should know what this a plus b plus c when divided by 4, what is its remainder? So is 249 divisible by 4? If not, what's its remainder when dividing by 4?
it's not divisible,
Okay, so what?
but it has a remainder of 1/4. So
Okay,
0.25.
so 1, right? So it's 1 plus a multiple of 4, right? Which is actually 62 times 4 plus 1, right? So what does this mean about the last number? How should it be a multiple of 4? If not, how much more than a multiple of 4 should it be?
It should be 3 more than a multiple of 4.
Good. So now of the possible values here, which is 3 more than a multiple of 4?
$71.
71, yes. So we had that before, but just to kind of double check that's the only one, you can think about, okay, so what should it be in terms of its remainder when dividing by 4? And in fact, with this approach, you don't even need to take these sums in this way, right? Because I could just look at, okay, what's the remainder when I divide 76 by 4, 82 by 4, and 91 by 4? Then I don't have to add these up to say 249, and then think about the sum and so on. So all I really care about is the sum needs to be divisible by 4, right? So I can think about, okay, does this divide by 4? If not, what is its remainder? What is this remainder when divided by 4? And so on. And the sum of that should be a multiple of 4. Okay, good. So we have the first 4. So now the fifth would have to be 80 to fill the 5. And then we can confirm that the first average is 76. Second average is 79. Third average is 81. 78 and 80, I believe, are the averages as you add them up, but this is the order of the 5 numbers. Does this make sense?
Yep.
Okay, good. Let's move to the last one. Okay. Any answers on this one? So it should be more than 1, but sun vy 1.
So what I did was, if it was 5 meters long and she can see exactly 1 kilometer horizontally in all directions, then it would basically form a circle, like 1/4 of a circle with a radius of 1. So I did that. I got the area would be 1 pi. And since it's 1/4 of a circle, that'd be 1/4 pi. And I got that. The closest whole number to that was 1.
Okay, good. Yeah, so this is true of 1 point. So let's say if she was standing here, this is true. So if I can see 1 kilometer from this point, I could see anywhere along the circle centered at this point that's 1 with a radius of 1 kilometer. So if she stood at this corner, she would see anywhere on this circle. Okay, but I think the kind of this question wants you to say, okay, if she's anywhere on the boundary, there's a region that she can see, right? So if she was at this point, she'll see at this circle. If she was at the center of this, she would see anywhere on this circle. Anywhere at this corner, she would see anywhere at this circle, and so on. So if I go along this, she walks completely around the boundary of the square. So at each point, there's a circle with radius 1 that kind of covers the area that she can see. So basically, imagine if you take the circle centered at each point on the square, it's encompassing some area, right? And we want the total area of all this that would be covered by the circle as it moves along this path. Does that make sense? So what would that look like? Let's think about first inside the square, what area is covered. So, and let's just think about one side. So if I travel from this circle to this point, what area in the circle am I covering? What area inside the square am I covering with the circle?
The radius?
Yeah, so it is this area from here to here, but as I move from this corner to this corner, as I move from this corner to this corner, I'm essentially covering this area. Anywhere within 1 kilometer inside this square. So anywhere in this region, would be visible. Does this make sense?
Yes.
Okay, so now let's do this on all the 4 sides. So what kind of shape would that create?
So each side would be, there would be a 5x1 rectangle, but then there's 4 sides that overlap. So it's 5 times 4 is 20, and then the minus the 4 extra pieces is 16.
Let's see. Good, yeah. So yes, that's correct. Now there's another way of doing this, which might make it a bit easier, is so let's take the total of these areas. So we're looking at that side, this side. I'm just shading these, this side, and this side. Can we express this as a difference between 2 areas rather than kind of adding up and subtracting the overlaps?
Oh, you could just do the 5x5, the entire square, minus the middle square, which is a 4x4.
Close.
It would be a 3x3.
3 by 3, yes. So the outside square is 5 by 5, the inside square is 3 by 3. So that's 25 minus 9, which is 16. So that part is good. Okay, so we have what's inside this square. What about the portion that's outside the square? So let's again start off with one side and then we'll extend to all the 4 sides.
So does it follow the same rule? So except now it's a 6x1 rectangular side per slab?
That's close. It
Or no,
actually,
7.
huh?
It would be 7. Wait.
Yes, so it is actually upper bounded by the 7. And actually that will probably give you a close enough answer. So yes, if we took a 7, so this rectangle would look something like this. With 7, so something like this, right? So that's very close. Why is that not exactly the answer?
Would it?
Oh, sorry.
No, it's fine. Go ahead.
Oh, okay. I was gonna say there's those corner pieces on the end. Yeah, right there.
Good.
And there's 4 of those. So we have to calculate for those.
So we're actually very close. So let's actually get what the answer would be if I just assumed that this didn't exist. What if we counted everything inside the 7 by 7 square? What would the answer be?
24 for the outside.
Good. So how did you get that?
There's 4 7x1 rectangles, and then just like last time, so that's 28, and there's the intersecting of 4, so those are overlaps, so that's
Good.
24.
Yeah, so you can do it that way. Can we also do it the way of doing the difference of squares?
Yeah. Now we can do a 7 squared is the big square, and then the smaller one is 5 squared. So that's 49 minus 25,
Is also
which
25.
is also 24. Sorry.
Good. Yeah. So 25. So if I didn't actually worry about those small areas, I would get 24 plus 16, which is 40. And this is also actually equal to saying 7 by 7 is the outer one, and 3 by 3 is this inner square. So I could do 49 minus 9 and get 40 that way also. That's very close. It's actually, if you round to the nearest whole number, it's off by 1. So now let's think about if I actually wanted to subtract out this area, any ideas of actually computing this area? Okay, I'm gonna draw these two lines. See if this,
Maybe, oh, okay.
yeah, go ahead.
I was gonna say, you can take the circumference of, or not circumference, the area of that quadrant and make that square that you made and then subtract the two.
Good. And what is that difference?
Um, so the radius would be 1, so just pi r. Or sorry, no. 1 squared r, so just 1 pi, or sorry, pi is for the entire thing. So it's pi by 4 for that quadrant. And then that square entirely is also is 1. So it's 1 minus pi over 4.
Good. So that's the area we want to remove, right? Now,
Yeah.
do we have to multiply this by something?
Multiplied by 4 because there's 4 corners that face that.
Good. Let's multiply this by 4. What do we get?
You just get 4 minus pi.
And what is this approximately?
1 point, or sorry, 0.9 something something something. So it would be, so if you round it, it would be 1-ish.
Sure. So let's say 4 minus 3.14 as pi, you'll get 0.86. So what should the answer be?
So now we can add 24 plus 16, which is 40, and then 40 plus the 0.86 is 40.86, and then round to the nearest whole number, so it's 41.
Almost there. Do we add the 0.86 or subtract it?
Subtract it, so it's 39.
Good. Yeah. Yeah. So almost there. Just so remember that we counted in the 40, we counted everything inside this larger square, right? So now we want to subtract out this area here, this, and this, which we computed was 0.86. So 40 minus 0.86 would be 39.14, which is approximately 39. So the answer would be 39. Good. Yes. The answer is 39. Any questions on this? Okay, that's it for today's class then. We'll see you next week.
Thank you.
Mhm.
Thank you.